طيب يا شباب بسم الله. So last time we talked about the applications of the steady state control volumes. We have talked about multiple engineering devices of interest, and we applied the energy balance and mass balance for each of these devices. We talked about nozzles and diffusers, and we applied the energy balance for this device. We talked about the turbines, where we generate power output, and then we also applied the energy balance, and we saw how we can evaluate the power output here. We looked at the compressors and pumps, and we saw what is the required power input in order to elevate the pressure of gases or liquids. We looked at the heat exchangers, and we saw the heat transfer is important in this case. And we looked also at the throttling devices, where we restrict the flow in order to significantly reduce the pressure. And we saw that the enthalpy at the inlet equals the enthalpy at the exit for idealized throttling process. And we also said that in most of or many engineering applications, two or more devices are combined together to achieve a certain objective, which we call system integration, like generating power from a power plant, which can use compressors, pumps, gas turbines, like steam turbines, etc. Okay. Any questions about this previous discussion? Today we'll take a couple of examples. And before I forget, Shabab, today I'll have an office hour, inshallah, from 1 p.m. Usually I'll have it from 1 to 2, but I can extend it this time for the exam, maybe to 2:30 or 3, depending on students if they're joining to ask questions. So if you have any questions, Shabab, about the exam or midterm, please come to me during the office hour. Okay? If you have any question about the material, concepts. The other thing, Shabab, as I mentioned in my instructions, the instructions are clear. Please print out the tables and charts. I will not accept the book, opening the book, okay? You cannot open the book. You cannot use the book for the exam. So please, I don't care about other professors, other instructors. I care about my sections, okay? So just follow my procedure carefully, Shabab. Is that clear? The other thing is that, Shabab, at 6:30, you need to join at 6:30, because it will take time to take attendance and explain to you the instructions again clearly, so that people are ready, or students are ready for the exam before at 7, because at 7 sharp we will start, inshallah, the exam. Okay, so I wanted to mention this before I forget. Okay, so as I said, today we'll take a couple of examples that applies the steady state control volume equations that we have seen before. Okay. Any questions so far? Okay, سؤال.
دكتور، أقدر أطبع طيب الكتاب، التيبلز اللي في الكتاب؟
وليش طيب الكتاب وش تفرق؟
تعودت عليه، ما أدري اللي في البلاك بورد نفسه ولا لا.
ما أدري بكيفك. اطبع لي. أهم شيء ما الكتاب ما تفتحه يعني. بس ترى هو اللي سويت له أبلودد نفسه اللي في الكتاب، بس قارن شوف يعني. You can compare. طيب. Okay. So, in this example, يا شباب, I have what I call a converging diverging nozzle. إيش يعني converging diverging nozzle? This type of nozzle, as you can see that the area is converging here. Converging means is reducing or some يعني in a way. So this is converging. So you see the area is reducing, then increasing again, or what we call diverge. Okay. So So that's why we call it converging diverging nozzle. And we have a steam, okay, running through this converging diverging nozzle. By the way, this converging diverging nozzle, we see it usually in high-speed applications, like for example jet engines or such applications, where the velocities is very high at the exit that can reach supersonic or sonic flows. Sonic flow is basically the speed of sound. So flows that can reach the speed of sound or higher than the speed of sound, basically. So this is why we use this type of converging diverging nozzles. So you can see here I have a steam entering this nozzle at a 40 bar and 400 degrees Celsius with a speed of 10 meters per second. The exit of this steam is also, it's state as steam. It exits at a pressure of 15 bar and a velocity of 665 meters per second. Okay, so you can see the speed here is very high. The speed increased very high here. And the operation of this steam is a steady state. We have one inlet, one exit, as you can see. And the question is find the area at the exit. Okay, so what we need to do here is to find the area at the exit in this case. So how can we proceed here? We have an inlet, we have an exit. I have pressure and temperature and velocity at the inlet. I have only pressure and velocity at the exit. So how can we find the area at the exit? So whenever you hear area, velocity, and you have a control volume, the one thing you can think of immediately for the first time is basically what? The mass flow rate equation. Okay, so you can see that the mass flow rate equation here equals velocity times area divided by specific volume. Okay, so velocity area divided by specific volume. So if I want to solve for area, so this becomes area equals m dot times specific volume divided by the velocity here. Okay, طيب what is given, what is missing. طبعا هذه يا شباب procedure. By the way, I hope you also follow this procedure in the midterm today. When you try to solve a problem, always start from the end. يعني كيف؟ يعني I ask you for the area, you write the equation that can be used to find area. Okay, I ask for any parameter, heat transfer, you write whatever equation you know that has heat transfer. يعني start from the end, try to find the equation that you can use immediately for the area, for the required value or required parameter here. Okay, فخلاص. طيب الحين كتبت الايكويشن حقت الاريا. What's next? I check every other parameter here and see what's given and what's missing. I look at m dot. M dot I give you here m dot. So the m dot is given. So this is given. The color. So m dot here is given. But what else? V2, which is the velocity here. Do I have it? Yes, I have V2. So this is another given information. طب ممتاز. I'm very close to the answer. What is specific volume? Now I need the specific volume. Is it given? I see here it's not given, so I need to find it. ممتاز. How can I find it? I look at the exit here and I see I'm given the pressure. So I only have the pressure. And now يا شباب, you are expert. You will use this. انتم عارفين انتم الحين المفروض انكم expert in evaluating properties. Okay? You will be tested on it today. Okay, how can I evaluate properties? You need two independent properties to find all other properties. Okay, so I look at this state here too. I have what? I have only pressure. So what do I need? I need a second property. Okay, so I need a second property in order to fix the state. Okay, طيب السؤال what is this second property? Okay, that's the question now. What is the second property that I should find? أي فكرة يا شباب؟ Anyone can think of any idea? What is the second property that I can use? Huh? So this is steady state control volume. Do I have a relationship between maybe the inlet and the exit maybe?
mass in minus mass out equal to 0.
طيب I know this already. This is mass balance. I have one inlet, one exit, and this is steady state, so m.1 equal m.2. But what's the benefit? What can I benefit from it يعني؟
تبي تطلع السبيسيفيك فوليوم.
You mean this will equal to m dot, sorry, this is not m dot. So basically you're saying m.1 equals to m.2, right? So I have what? V1 A1 over V1 equal V2 A2 over V2 كده. So I have V1, I have V2, so I'm missing this one, but I can't find it. Why? Because I have P1 and T1. Okay, excellent. طيب, and this is what I need, V2, right? But what's missing? I don't know this one, and I also don't know this one. So this is not given. So I cannot use it. What other option do I have? This is a good thinking and good try. What else? Is there other way? Maybe?
Doctor, should it be giving the
لا ما أعطيتك الاريا at one.
ratio? I mean the ratio between A1 and A2.
لا ما في ratio, ما في شيء. And do not assume things, please. Do not assume things that are not given. Do not assume oh maybe A1 equals A2 على طول أسوي كذا وأروح أحل. No. This is wrong. Okay, if it doesn't tell you, do not assume, especially like this يعني for mass flow rate, for okay, unless you know it is, let's say, clear it's a pipe مثلا خلاص it's a constant pipe. For this case, yes, you can cancel, but this is converging diverging, it's not necessarily the same. Any other option?
Doctor, can we assume that energy is constant?
كيف energy is constant؟ ما فهم.
The internal energy.
وعلى أي أساس you assume it's constant؟ البريشر هنا تغير، معناته الانترنال انرجي بتتغير. What other equation is there for this case? What can you think of other equation other than the mass flow rate? إيش في equation غير الماس flow rate؟ شباب، بشوات. ايش فيكم؟ ما في احد يقول ما energy balance؟ يعني ما حد كذا فكر في energy balance يعني مرة؟
إلا بس صح،
بس ايش؟
بس ما أدري، أحس ما
كيف ما له علاقة؟ الحين الانرجي بالانس وش تعطيك؟
تعطيني الكيو والورك والدلتا يو.
طيب you have Q minus work plus M dot H1 minus H2 plus kinetic energy different.
بس دكتور يعني انا ما قلت لك ان الانرجي كونستنت.
الانرجي انت قلت internal energy. internal energy is a property.
الحين هذا يساوي صفر، والصفر هي الانترنال انرجي ولا؟
لا
الحين هذا مو بالفيرست لو في الثيرمودايناميك.
هذا الفيرست law of thermodynamics. شوف الانرجي the change of energy هذه دقيقة dt equal to 0. طيب انت كان قصدك كذا يعني؟
اي الدلتا اي.
طيب انت ما كملت. طيب كمل. قل لي والله the change of energy of the system is 0 because of steady state, then I can apply the first law. طيب وش كانت ال continuation ولا خلاص يعني؟
لا كانت ما صراحة ما حفظت المعادلة.
فبالتالي هنا شوف this is the first law, this is steady state, you have Q minus W. الحين لما تجي تطالع في ال converging diverging we can neglect heat transfer and there is no work, we don't see any work done here, so we can say this is 0. So I can solve for the enthalpy at the second state as a function of the enthalpy at the first state, the inlet, plus the difference in velocities, kinetic energy. Okay, so basically I can find the second property using the energy balance اللي هو first law. Okay شباب, so that's the idea here. So the idea here is we apply the first law and we find the enthalpy at the exit state from this equation because I can neglect W and Q. M dot here eventually it will be 0 لأنه you're gonna divide by 0 over M dot, so this is 0. Then you're left with H1 minus H2 plus V1 squared minus V2 squared over 2 equal to 0. So then you can solve for H2. Okay, فبالتالي تطالع في الايكويشن هذه عندي H1 I can find it from P1 and T1 وعندك اعطيتك given ال V1 و V2 خلاص you can find H2 فيصير عندك ايش؟ P2 and يعني pressure at exit and enthalpy at the exit, and this is what we can do here. So at state 1 or inlet state at P1 and T1 I can find H1 from the steam tables or the superheated water table. Then I can find H2 here. Don't forget to unify the units. Divide by 1000 here to get kilojoule. Then you get this value for the enthalpy at the exit. Okay? Then that's it. You have P2 and H2. Still you are in the superheated table. You go and get the specific volume at the exit state. You might need to do triple interpolation in this case. Okay? That's it. طلعت ال V2 خلاص. We go back to the original equation and evaluate the specific volume. Okay, so that's the idea here يا شباب. So again the procedure to go through the problem is very important. You start from the end, you see what's missing, you see what's given, and then you calculate back until you go back and evaluate the original equation that you will use to evaluate what's needed to be found. Okay, so this is in this way you can be systematic and clear, and you'll be able inshallah to solve the problem. So then we go back and evaluate this specific volume, and we get the area is around 5 this is going to be centimeters squared. Okay, any questions here? Any questions about this example? You see, it's a simple example, but it requires the use of the mass flow rate equation and the energy balance equation, first law of thermodynamics. Okay? Questions before we move to another problem? طيب. The other problem here, ya shabab, is the following. This is a problem where I have a pump, okay? This is a water pump, is drawing water from some lake or river or whatever, 10 meters above a hill. زي الهضبة والجبل الصغير is drawing water 10 meters above the inlet point here, okay? So the reference, I have 0, Z1 equals 0 here, and Z10, Z2 equal 10 meter here, okay? So here in this case, I cannot neglect the potential energy. The potential energy here is important. The state of this water at the inlet is 20 degrees Celsius and 1 atmosphere, and the diameter of the inlet of this pipe is 12 centimeter in this case. And I'm also giving you the volumetric flow rate at the inlet, which is area times velocity, which is 0.83 meter cubed per minute. Okay, so this is per minute, 0.83 meter cubed per minute. So a little bit less than 1 meter cubed per minute. So the exit here, shabab, I have a smaller diameter of 3 centimeter, and the temperature and pressure at the inlet exit state is same as the inlet state, okay? So P2 equals to P1 and T2 equals to T1, okay? During this pump operating at steady state, there is heat dissipated into the environment, and the value of this heat dissipation is Q dot is as a function of the power input to the pump, which is 0.05, or we can say this is 5% of the power input, okay? So the heat transfer is 5% of the power input to the pump. Okay, so this is a pump, so there is a power input required to run this pump in order to elevate the pressure or elevate the water from this location to this location. The question is find the velocities at the inlet and the exit, and the second is find the power input to the pump. Okay, so these are the two problems in this case here. And as you can see, shabab, here in the solution for the first part, again, since this is velocity, so for velocity and area, etc., I can think of first the mass flow rate equation. So from the mass flow rate equation, I have what? I have V1 equals m dot times specific volume at the inlet state divided by the area at the inlet state. Okay, so if you look at this equation, and at the exit is similar, the velocity at the exit is m dot times V2 over A2. Here we have the specific volume at the exit, area at the exit. Since this is one inlet, one exit pump, I have m dot 1 equals to m dot 2 equals to m dot. Okay, so this is a mass balance, and this is the equation that we can use to find the velocity. Similar procedure, we will follow exactly the same as we did in the previous example. Let's check what's given and what's missing. Area, do I have area? I have the diameters for each inlet and exit, so I can calculate the area from the area of a circle. So this is pi over 4d squared. So basically I can find area at inlet and area at exit. Done. Type. What else? Do I have m dot? Shabab, do I have m dot here? Or can I find m dot? M dot is what? M dot is the mass flow rate. Okay. And if you notice at the inlet, I give you what? The volumetric flow rate. So m dot equals VA 1 divided by specific volume at state 1. So basically, I can find m dot by dividing this 0.83 meter cube per minute divided by the specific volume at the inlet, and I do have the temperature and pressure, so I can find the specific volume. So I'm good here. Okay, so in this case, I'm good to find the mass flow rate. So this one can be found. V1, as we said, we found V1 here. Done. What about V2 here, ya shabab? Temperature and pressure is the same as the inlet at the exit. So this is V1 specific volume at 1 equals specific volume 2. That's it. Now this is the procedure. I planned my procedure. I know what's missing. I know how can I find it. And I continue the solution. So this is what I do. So at state 1, I have pressure and temperature. I can find the specific volume, which can be approximated at the saturated liquid state at 20 degrees Celsius, which is 0.001002 meter cube per kilogram. Divide the volumetric flow rate. I divide by 60 here to get seconds to be NSI units. Please, ya shabab, be careful. Even the exam today, be careful with the units. Always write units. Whenever you write a number, you have to have a unit. Okay? Don't write numbers without units. You will miss points. I will deduct points. So, you have the volumetric flow rate divided by the specific volume, and you get the mass flow rate as 13.81 kilograms per second. Okay? So, the velocity, so now that's it. Now I have the m dot, I have basically m dot, and I have specific volume. Then I can just simply evaluate the equation for the velocities. 13.81, which is the m dot, multiplied by the specific volume divided by the area. The only thing different between V1 and V2 is the area. Here I have 12 centimeter, here I have 3 centimeter. If you use the smaller diameter, you can see that I have higher velocity. So at the exit, and we have talked about this last time, if you have smaller diameter, as you decrease the diameter, you actually increase the velocity. Okay, so basically the velocity at inlet is 1.22 meter per second, and that is at the exit is almost 20 meter per second. Any questions about the first part? Any questions about the first part? طيب, how can I find the power input? How can I find the power input?
Delta E equal 0 for the system.
طيب, ممتاز. This is steady state. I can apply the similar energy balance like the previous example. So I apply the energy balance. If you notice, when I apply the energy balance, I have Q dot minus W dot plus M dot. H1 minus H2, ya shabab, since temperatures are equal at inlet and exit and pressure is equal at inlet and exit, what is the enthalpy is also equal. Okay, so H1 minus H2 basically cancels out, so this is 0. Then you are left with the kinetic energy, which is the velocities I have here calculated, and the potential energy, ya shabab, which is important in this case because I have elevation here. So do not ignore the potential because you have elevation. Here you see there is significant elevation. All right. So that's it. You can apply the 0.05 W dot, which is the Q dot here given in this case. Then you solve for the W dot here, which becomes M dot over 0.95 times this difference in velocity plus this difference in potential energy. If you notice, ya shabab, here when I applied, خلاص يعني now I'm plugging numbers. But I want you to be careful with the Z here. GZ1 minus Z2, do not just put 10. Yani some students make mistake and they put the difference, which is 10 meter. You need to reference it. You need to use Z1 as a reference value and Z2 is the elevation value. So Z1 is 0 minus 10. Okay, so this is 0 minus 10, which gives you that the potential energy, okay, is gravity is going downwards. Okay, so this is 0 minus 10. Be careful about this. Then this is just V1 squared minus V2 squared. The final equation here I divided by 1000 to get in kilowatt. So the final answer is minus 4.2 kilowatt, which means this is power input, which is negative. So it's work done on the system, which is negative according to our convention. So my calculation here is correct. أي سؤال هنا يا شباب؟ Any questions here?
دكتور انت تقول الريفرنس انه
زي ديتم
الاليفيشن
يعني ايه زي ديتم.
طب ليش ما نحط الديفرنس بس؟
بيطلع غلط لانه Z1 الايكويشن الاساس في شيء Z1 minus Z2. Z1 refers to what? The location of ايش؟ The location of the inlet. This is Z1 minus Z2, which is the location of the exit.
يعني الدكتور ريفرنس معطينا اياه في الكويستشن مو انا اللي اختار.
لا انت تشوف، انت تقيم البروبلم. Z1 is the location elevation، خلينا نقول بشكل آخر. الاليفيشن حق ايش؟ الاليفيشن حق الانلت حقك. Z2 is the elevation of the exit. انت الريفرنس حقك وشو عادة؟ زيرو اللي هو الأرض، أو خلينا نقول لك شو اسمه in this case here يعني lower point. Okay, this is Z1. My Z1 is the inlet here. I can think of it as this is يعني in the level ground. Now I'm pushing this 10 meter higher up. So Z2 is plus 10. لو كان this is taking it down, my Z2 will be what؟ يعني تخيل الحين Z1 هنا والبامب بيسحبه وينزله تحت somewhere below. هذا وش بيصير؟ Z2 ها، يعني تخيل معي انه البامب مو كذا، البامب كذا بيسحب مويه من هنا وينزلها تحت. So this is 2 and this is 1. So this is Z1 equal, this is my inlet, I will use it as 0. This is 10, so this is Z2. This is gonna be minus 10 لو قلنا ان هذا 10. It depends on the problem. You need to have a 0 point. Usually at the inlet, this is your 0. If it is up, this is plus. If it is below, this is minus. In terms of elevation, Z. That's why here, when we put it here, يعني انت تقدر تشوفها هنا. 0 minus 10 is what? Is minus 10. Okay? عشان كذا لو تحط 10 الفرق بتغلط. يصير جوابك غلط. ما ادري وضحت ولا؟
اي واضحه.
It's just following conventions، يعني following اللي هو sign convention نسميه. زي فكرة ال Q into the system is plus, out of the system is negative, work done on the system is negative, work done by the system is positive. This is the same thing. Elevation above the ground is plus, elevation below is negative. And you need to use Z1 and Z2. Do not just use a difference and this the potential, this the difference. يمكن تصدف معاك في واحدة من problems لكن in this case it will be wrong if you use just value. طيب any other questions? Any other questions? طيب شباب, as I said, inshallah at 1 today I will have an office hour. I'll leave you early if you want to study or do something else. But and we'll meet inshallah tonight at 6:30 يا شباب. Okay, موفقين بإذن الله.
شكرا
دكتور.
دكتور.
هلا.
في بس مسألة اللي هي تصوير الأسئلة. في كل مرة أصور الكفر بيج في كل سؤال.
صحيح. يعني عشان الفايل اللي هو attach, لأنه الاتاتشمنت كل سؤال له attachment button مختلف, وكل button تصور لي الكفر بيج مع السؤال. اوكي.
بس
دكتور،
لأنه
في
مكتوب في
مجال
السبمشن, معليش, بس مكتوب في السبمشن 5 pages. make sure to be 5 pages. فكذا يعني المفروض يكون 8, صح؟
لا أنت قصدك اللي في الكفر بيج, قصدهم لأنه في كل سؤال في صفحة والكفر بيج 5, بس هذه في الفيزيكال لو كان فيزيكال. don't worry about this.
دكتور, في مجال إنه يكون سمت جميع الأسئلة مع بعض.
والله ما في مجال
دكتور, لأن يعني 25 دقيقة أو 20 دقيقة للسؤال مع السمت, لازم إنه تطلع تسوي سكان وترجع.
مظبوط.
حتى تسبب مشكلة.
شوف أنت في الأخير عندك, so that's why I wanted to come at 6:30 we talk about this. لكن أنت عندك في الأخير وشو عندك 5 minutes submission و 5 minutes to reposition the camera. يعني خلينا نقول عندك 10 minutes to scan and submit and come back. اوكي, بعد كل سؤال. فإن شاء الله you can do it يعني.
شكرا دكتور.
هيا. موفقين يا شباب.
يعطيك العافية دكتور.
الله يعافيك. هيا.